Hi, welcome to this video. This is Priyadarshan, Department of Computer Science Engineering, Assistant Professor in Hindustan College of Engineering and Technology. In this video, we are going to see about data link layer, how it works in computer networks. In this computer networks, we are having 7 layers. That layers consist of packet transmission from hardware devices to the end devices. It consists of 7 layers. That is, it starts from physical layer, data link layer, network layer, session layer, transport layer, then presentation layer and the application layer. From the physical layer, how the data are converted into frames, bits, packets to the destination address. In this, I have included the contents of the foundations of data link layer, the functions of data link layer, where the data link layer has been located in the OSI model, and how the framing has been done in the network layer. Then, obviously, when we are doing the framing functions, also we should include the error detection and correction techniques, the protocols which is being included in the layer 2, then the physical addressing and access media which is used for the MAC, that is media access control. The first slide, which is defines the foundations of how the communication, that is the node to node communication, has been done from the source to destination protocol process. In this process, we are bridging the gap between the physical hardware devices with the network protocol. That is, what are all the physical devices such as wires, cables, the Ethernet connections. These are all the connections. From that connections, how the data can be converted to the bits, and also this data link layer ensures the reliable communications between the source and destination devices. This is highlighting in the OSI model at the layer of 2. It is also responsible for the delivery of node to node communication of the data inside the local network, that is the same local network. The major role of this data link layer is to ensure the error free, that is collision or error control free transmission of our data. Also responsible for error encoding, decoding, organizing the outgoing and incoming data which is being sent and back to the destination devices. In this 7 layers, this is being considered as the most complex layer of the OSI model because it hides all the major functions and complexities of the hardware from the above layers. All the process has been done inside the data link layer, the level 2. And the functions of main data link layers first starts from the framing, then error control, flow control. These three are categorized under the data link layer services, and also access control, physical addressing. Let's see briefly on the other slide. In devices which we are using at the layer 2 is normally we are using 3 main hardware devices to forward our packets or routing our packets. The first hardware devices switches. Obviously we know switches is the hardware device which is used to forward the frames which is being comes from the physical layer, has been transmitted to the transport layer or else network layer using the MAC address. In this phase we have to know the differentiation between the MAC address and the IP address. Whereas when you are using the IP address, it is used to find out where the network has been located. But in the case of a MAC address, this is mainly used to identify where the device has been located. That is, device locations has been identified by the media access control address. So next one is bridges. This is used to connect LAN segments. That is old. This is kind of an older technique which has been used to connect multiple LAN segments. Obviously, NIC card, that is network interface card, which is used at the which is being used as a hardware device for receiving the data from the other layers to transmit into the depends on the device. Next one is visual. This visual is used to do switching the forwarding packets in the frame based MAC table. That is MAC having some addressing table. This is called as a visual point. The next we are having comparison of those hardware devices. Normally, if I am referring a hub is a multi-port repeater. The main the main function of the hub is to it delivers the packet to the devices which are all the possibilities or which are all the devices has been connected on the all networks. it doesn't deliver the packet to the particular destination. It is deliver the packets to the all destination which has been connected through the hub multi-port repeater. So this is one of the simplest way to create a network, but even though we are having a disadvantage because of we cannot able to send or throw the packet to particular destination, so that we are overcoming that disadvantage by the way of switch. Before the switch, we have to know about the bridges. This is somewhat more advantages like the hub. From the hub, the packet has been processed on MAC address, that is inside of the hardware devices. Normally, MAC address is the hexadecimal address. It consists of a unique identification number of a manufacturer who is creating that particular devices inside the packets. The bridge is used to connect multi hubs inside it. That is, two or more hubs can be interconnected by the way of bridge. The last one is switch. This is the most wider hardware devices which is used for forwarding the packets to the networks. It can be used to connect multiple bridges into it, so that it is more scalable and also practically used. Bridge is not very useful for every end computing devices, but in case of a switch, it can be used for every devices. And also hubs cannot handle the large kind of a data traffic, that is large network traffic. It cannot use it. The next one is framing functions. Already we have seen in the DLC services. The framing is a process. Has been done in the network layer. From the physical layer, all the data has been comes like in the form of bits. This each and individual bits are divided into the small chunks. These individual chunks are named as frames. These frames starts from the payloads. I'm telling you about the frame structure. The first, it has the flag structure. Followed by the flag, it has the header. Followed by the header, it has the payload. Payload is defined as the original data which is being sent by the sender. Followed by the payload, we are having a trailer. In that trailer, that frame is used to process the error control or collision avoidance technique. The last one is ending flag. These are the flag's purpose is to normally in the flag operations, we are having 5 to 6 operations of flag. That is starting from the start, push, synchronization, rest, acknowledgement and stop. These are all the 6 flag services which is raised while any traffic over the networks, any delay over the networks, if there are error techniques, or else the packets cannot be forwarded to the next hop due to the network unavailability. From these kind of phases, flag will arises about SYN. If it is SYN flag arises, the packets are being synchronized over the network to push into the next hop. Same like byte count. Obviously, we know the byte count. Header specifies the frame length. That byte specifies the frame total length. The flag bytes is a sequence of zeros and one. It starts with start flag and the end flag. The visual structure is header. Already I have said you. The visual structure is header, payload. The next one is trailer. These are all the techniques which is being done inside the structure of trailer. Detection of error and correction of error. And why we have to use these error detection and correction? Because of by using the CRC, that is cycle redundancy check, we can able to calculate the checksum, how many times the packet has been forwarded through, how many times it has been avoid the errors. These are deducted the errors by the way of FEC, that is forward error correction. How many times of error has been resolved in that particular packet, that is called as example of this processing, the Hamming codes. Why we have to do those things is it is to ensure the data integrity over the noisy networks. Noisy networks means misconceptions of data, mislead of data, loss of data. These are the misconceptions. The visual structure can be, while calculating the cycle redundancy check, we have to fetch the binary data plus addition of checksum. The next, these are all the main key protocol being used in the data link layer to transmit the packet to the next network layer, that is Ethernet, triple P, that is defined as point-to-point protocol. The next one is the HTLC framework. This is a high-level data link framework to forward the packets from the data link layer to the network layer. Obviously, we are using the Wi-Fi, the standard of IEEE 802.11. Physical addressing, that is also called as a MAC addressing. I have already said MAC address is the 48-bit unique identifier with the hexadecimal presentation. It starts from 00. The first three octet, that is each and every 00, 1A, 2B is called as octet. The first three octet will define the unique number of the manufacturer. The next three will find out the device location and the error-free processes. These all hexadecimal unique identifier will be burned into the NIC card. The NIC card is to receive the data from the other devices. Main role of this physical addressing, it is to direct the frame to the correct devices on the LAN. That is, find out the exact device on the network which we have connected. The visual diagram may be the 6 hexadecimal pair, that is I have already said. Always the MAC address will be the combination of alphanumeric numbers, that is not alphanumeric, alphabetic, that right, alphanumeric number. The access control mainly used for it is to avoid the collision and detect the collision, that is called as CD, collision detection and collision avoidance. In the phase of collision detection, it is mentioned as listen before sending, that is before sending the packet we have to keen watch on that particular collision. We have to detect the collision. While the collision has been resolved, we can able to forward the packet. But in the case of a CA, no collision detection in this wireless. It will just avoid the collisions. It won't resolve all those collisions. Same like a token passing, it passes the token to transmit the packets from the packets in the shared media. It consists of a visual representation as collision detection real-time based scenario. Thank you for listening and thank you for watching this video. I hope so this video will be very informative to you. Thank you for watching this. Thanks a lot.